Prove that the roots of the equation 2kx squared plus 5x minus k equals 0 are real and distinct for all real values of k. Now, we know that whenever we are referring to real and distinct roots, it means b squared minus 4ac is greater than 0. b squared minus 4ac is the discriminant. In this term, a refers to the coefficient of x squared, b refers to the coefficient of x, and c refers to the constant. Now, if we can prove that for all real values of k, the discriminant is greater than 0, we would have shown the proof. So let's input the values into b squared minus 4ac. So b is 5, and a is 2k, and c is negative k. Now this gives us 25 plus 8k squared. Great. Now we're going to break this down into two sections. We will look at 8k squared first, and then we'll move on to 25 plus 8k. Now in this section, we see that k squared is greater than 0, and that is because the square of any real number is positive. And we know that 8k squared is greater than 0 because the product of two positive real numbers is positive. Now taking a look at 25 plus 8k, we know that the sum of two positive real numbers is also positive. Therefore, 25 plus 8k squared is greater than 0. This obviously implies b squared minus 4ac is greater than 0. Therefore, we have real and distinct roots. And our proof is done.